So let's jump straight into Fabric and see if we can start setting this up. So I promised you entirely from scratch. So, of course, the first thing we need to do is create a new workspace. Let's call it a demo, and then at least it will appear at the top of my list, easier to find. And we just need to make sure that it's either a Fabric capacity, or I'm going to use a trial. Just hit apply, and we'll get a new workspace created, completely empty. And you can see at the moment, down in the bottom left-hand corner, I'm using the Power BI persona. So I'm going to switch that into real-time analytics, and we get a slightly different home screen here with a different set of artifacts that we can create at the top. So I'm going to start by creating an event stream. An event stream. I'm really unimaginative at names, especially under pressure, so don't judge me on that. So event streams will just take a couple of moments just to initialize inside of Fabric, and then we can start configuring it. Here we are. So here's our, is that big enough to see, by the way, on the big screen? Yeah. So we've got an empty event stream. We need to configure where the data is going to come from and where the data is going to come to. So I'm going to create a new source. And we get multiple options in here. We can use some of Microsoft's sample data, but that's low risk and not real, right? So we're not going to do that. We can pull in some events from Azure. So it supports either Azure Event Hub or Azure IoT Hub, but we want to stick entirely inside of the Fabric ecosystem. So I'm going to choose Custom App. And what this will do is it will create me the equivalent of Event Hub, but inside of Fabric, so I don't need to deploy any Azure resources at all. What should we call it? Data source, something like that. It doesn't really matter what you call these. And that very quickly initiates this Event Hub. So you see down the bottom we get the option of choosing different types of protocol to connect to, but we're going to stick with Event Hub. And if I pick keys here, this will give me the connection string that I need from my .NET app to be able to start pushing data into the Event Hub. So let me show you, well, let's tell you what, before we have a look at the .NET app, let me show you what our data source looks like. So you've seen a picture of a physical device. Let me connect to that, and I'll show you what the data looks like. So I'm using, I'm using one provided by FlightAware. The nice thing is it gives you some software that runs on the Raspberry Pi, so you don't even need to do any coding there. And just to give you a little preview of what we're trying to achieve, it comes kind of with a local version of Flight Radar 24, or FlightAware's equivalent. And what this map's showing us is the planes that my little Raspberry Pi can see right now. But obviously this is cheating. What we want to do is reproduce this map inside of Microsoft Fabric. But you can see at the moment, I can currently see 55 aircraft flying up above us. And if I zoom in far enough, so here we are in Farnham. Oh, not Farnham, sorry, Farnborough, aren't we? But there's a little private jet there, and there's another one there that looks like it might be coming into land in Farnborough. But obviously, we can't suck the data out of the map. That's not what we want to be doing. We want to be taking that raw transponder data. So conveniently, this software also provides me with a JSON view of this data. And as I hit refresh, you'll see that that data is constantly changing. So it's, it's live. It's exactly what that transponder data is visible right this second. And if I just scroll through it quickly, you can see it's basically an array of aircraft. So each aircraft that it can see has its own little chunk of JSON here. And it's not uniform. Different aircraft are broadcasting different types of information. But on the whole, they all have what's called hex. This is a unique identifier for that aircraft. And actually, you can use that hex code to look up against external metadata, and it will tell you, who the operator is, who owns the plane, and what type of plane, all of that kind of information. For some aircraft, we also get flight number. So we should be able to see, it's British Airways flight 995 to Seattle or whatever. And hopefully, we will also get a longitude and latitude to show us where that plane is. We should also get some other information like altitude and compass bearing and that kind of thing, so we can see how high the plane is and which direction it's traveling. So what my little .NET app does, it's only a few lines of code. I'll just walk you through them very quickly. I'm not a .NET developer, so no excuses for the probably terrible code that's using deprecated libraries or whatever. But I'm creating a little web client. And then with that web client, what I'm going to do is have a timer in here, which ticks every 5 seconds. So every 5 seconds when that timer ticks, it uses that web client to access that JSON, then pass through the array of aircraft. And then, so for every single aircraft, what it's going to do is create a batch of events, and then once it's gone through all of the aircraft, it's going to write that batch into Microsoft Fabric. I'm actually doing a couple of other things here. I'm also cleaning up some of the nested arrays that sometimes happens in that JSON, not because Eventstream has any problem with it, not because KQL DB has any problems with it, but actually in the early preview of Data Activator, sometimes it quite badly broke Data Activator. That might be fixed now, but I'm not going to risk it for the demo. I'm also writing in the date captured, because the thing with, or the time captured more importantly, because the thing with streaming data is, whilst we're pushing it in real time, it doesn't always necessarily guarantee that that data is going to arrive in the same sequence as we sent it. So if I capture the date that we get the data, then I can make sure that when we come to display it at the other end, it's appearing in the right order. Otherwise, our planes might start flying backwards. And that's basically it. So I've got that connection string to the Event Hub. I'm just going to paste that in there. So I should see that updated. And click play. And hopefully, we'll get our little app running. Obviously, it won't do anything for 5 seconds. And then I'm just outputting it just so we can check that it's working. So this is a JSON now that's being transmitted into Eventstream. So let's go back to Eventstream. And hopefully, sometimes it takes a few moments, if I click on this, we should get a little preview of the data as it's now appearing inside of our Fabric environment. There we go. So we get that hex field, the flight, and all of those other fields that we saw. And interestingly, I see there's been a new release of Fabric since last night, and the UI looks pretty good now. It's coping quite nicely with that irregular number of columns. If we saw this yesterday, we'd see that that table was a little bit all over the place. This is actually a big improvement. OK, so we're sucking data in. Now we need somewhere to put it. So we're going to store it inside of a KQL database, which gives us the ability to store large amounts of data for long amounts of time and then be able to query it with really great performance. So I'm going to jump back to my workspace and create a KQL DB. Let's call it KQL DB, in keeping with my imaginative naming. Just take a moment to initiate, and we get a completely empty KQL database ready to go. So now if I jump back to the event stream, we can configure that destination. So choose destination. So we got a few options here. We can push straight out to another API if we wanted our own, fully custom JavaScript web interface, for example. We can push live streaming data into that. We can push data straight into the lake. If we don't need to do any real-time analytics on it using KQL DB, we can just go direct to Lakehouse and then use OneLake on top of it. I can push it out to Data Activator and create a new reflex. So reflex is the artifact that you create in Data Activator. but we're going to choose KQL DB. And here we get the choice of whether we want to do some manipulation on that data first, or whether we want to push it straight into our database. Now, I'm not going to show the manipulation, but the kind of things you can do, you can aggregate that data, you can filter it, you can join it in with other sources. So it's basically a fabric version of the Stream Analytics interface. But we're not going to worry about that here. We're just going to push the raw data straight into our database. So we'll just configure that. So give it a name. Choose our workspace, because you can push the databases in other workspaces. This is why I called it a demo, so it's at the top. And then we can pick our new empty database. So you see, it's quite a nice graphical user interface, no code at all required yet. Chosen our empty database, create a new table. Let's call that flight data. A little bit more descriptive, perhaps, than my others. Hit next, and what that's going to do is it's going to create that flight data table for us, and it's going to analyze the first 50 rows of our streaming data that it gets and configure the appropriate columns in that table, choosing the data types based on the kind of data that it's seen so far. You can go through and edit them if you want. So, if you've got a numerical column that you think should be a string because it hasn't had all of the right kind of data through yet, you can go and tweak that. I'm going to risk it and hope it's got enough data to have set these up correctly. So I'll just let that complete until I see a happy tick and hit close. And happily, we've got a nice little green tick here saying that it's started to ingest that data. So this is a good start. I'm streaming data in. It's going through Eventstream and hopefully now being saved into our KQL DB. So let's go and check. So if I go back to our database, quick thing to do is I can just click Explore My Data, and gives you a nice little template that you can just tweak with your own table name. So let's have a look at the first 100 rows of data. Now, in all likelihood, there'll be nothing in here yet, because just to stress me out when I'm doing demos, it takes a couple of minutes just to get everything set up and initialized behind the scenes. But let's try. Oh, no, we're good. So all working nicely today. So we already got data in our table. It's been probably a couple of minutes since we set it up, so let's just check how many rows we've got. 722 rows already, just while I've been talking for the last few moments. So fairly happy, things are coming in as I want them to. Now I'm ready to start prepping that data ready to display in my presentation layer in Power BI. Now, in order to do that, what I don't want to do is expose the whole of my flight data table to Power BI, because might only had 700 odd rows today. If I come back in a month or two, it's going to have hundreds of thousands, hundreds of millions of rows in there. So I've been running this actually now, obviously a different database, for about 6 months, and I've got around about 500 million rows of data in there, and it's still running reliably. It fell over once, but I think that was my fault. It's continuing to work, and I've now set a maximum limit that you can do on tables in KQL, so that you only keep, say, 6 months worth of data on a rolling window, so that it's not growing and growing and growing with more data than you're ever going to query. Okay, so let's go back to my workspace, and I'm going to create a new artifact in here. So I'm going to create something called a KQL query set. And a KQL query set is a bit like the notebook experience for KQL. So I'm just going to hook it up to our database, which is that one in our current workspace. And then, because KQL is relatively new for me, and I'm not brave enough to write it in front of you lot just yet, I'm going to paste in some code that I've already written, but I'll walk through it. So what I want to do in Power BI is I want to display, say, last 5 minutes worth of data. So if I take our flight data table, make it bigger, and I can say, take the flight data where the ingestion time was in the last 5 minutes. So if I hit run, now we only get 2,000 records back, which should relate to the last 5 minutes. But if you have a look down here, where's our longitude and latitude columns, you'll notice that there's some gaps. We've got records in here where the plane hasn't transmitted its location. Well, that's not a lot of use to me if I want to display that in Power BI. I only really want the records where I know where the planes are. So my next row filters all of the rows out where there isn't a longitude record. So if I run that, we get a table with all of the information that I can actually report on. But wouldn't it be nice in Power BI if I could choose whether I want 5 minutes worth of data or 20 minutes worth of data or a day's worth of data? So what we're going to do is parameterize that amount of time. So I'm going to create a function in KQL. And it's quite a simple function. It's just basically using that query we used on the line above and parameterizing the amount of time. So let's run that. And then so I've created a function called flight history. And then I can pass in the amount of time. So in this case, 5 minutes. Let's change it to 10 minutes. And I'll get the same results back as I've just shown you, but with a parameterized time. So I'm going to jump into Power BI now, and we're going to call this function. So blank Power BI report. And there's a reason, actually, that I'm doing this inside of Power BI Desktop and not the service. At the moment in the Power BI service, we can't call these functions and parameterize them. At the moment, we can only do this in Desktop. But obviously, once I've created it in Desktop, then I can publish it up to the service. Fine. So we need to get some data. So hit Get Data. And since the February version of Power BI, we get the option to choose Microsoft Fabric, and I can happily just choose KQL database. These are all of my databases, so I'll hit our new one. Authenticate quickly. And here we are connected up to KQL DB inside of Fabric, and you can see that we've got our raw flight data table where we're storing everything, and we've also got our function. So we're going to call the function, and I need to pass in that parameter amount. And I can never remember what format we have to use for this value, and it won't accept 5 minutes like you would actually call the function in KQL DB. So I'm just going to put 5 in. That will actually be 5 days, and I'll go back and tweak it in a minute. But that's all we need to do. I'll just hit load. And we get the option of whether it's going to be import or direct query. Now, if I chose import, that would do a one-time load into our Power BI data set. And then, obviously, the planes are constantly moving. If we want to update the report with the latest positions of a plane, we'd have to refresh that Power BI data set, which we don't want to have to do because you can't do that frequently enough in Power BI to have near real-time data. So I'm going to choose direct query. Now, direct query is not something I'd normally recommend if we're connecting to a SQL database. You know, always OneLake or Power BI import model. But actually with KQL is such a powerful engine that, you know, as you'll see, the performance is really good even with a direct query connection. So here's our flight history, all of the fields that we've pulled in. Let's have a little quick go, an initial go at plotting it on a map so we can see where our planes are. So let's use Azure Maps. And we've got longitude and latitude data, so let's just drag that in to the appropriate fields. Come on, don't let me down. Ah, thank you. Phew. There we go. That's a relief. And we can see now where we've picked up the locations of those aircraft. And you can see it's actually covered quite a large area just with that little antenna in my attic. We can see quite a long way. And I can zoom all the way into Farnborough. Look, you can see there's some planes doing circles there. But it doesn't look like anybody's taken off from Farnborough Airport. And in fact, if they had, we'd have probably heard it. Now, this is all right, but it's not Flight Radar 24, is it? I can't really tell which plane is which. I can't tell which direction the planes are flying in. And we've got these great big gaps where we haven't received any data for a few seconds. So let's see if we can do a better job. What I would like to do is draw the lines in the same way as we have in Flight Radar 24 on the map, and I want a picture of a plane pointing in the right direction. So let's jump back into Fabric and see if we can improve on our query a little bit. So what I need to be able to do is capture those longitudes and latitudes, but know for each plane which order they arrived in. So I know that this is the first record I received versus last record I received, and I can plot a line, you know, with the points in the correct order. Let me show you the outcome of this. So basically, same query as we had before, last 5 minutes worth of data, where we've got longitude and latitude data. I'm going to sort it by that unique ID for the plane. I'm going to create a new field which combines longitude and latitude, which I'll show you why in Power BI in a second. But the important bit is I'm going to create effectively a rank or an index for each of those planes. So let me run that. Remove, so this project column just lets us pick the columns we want out of our query, so we've not got all of that junk on the side, and we get a nice, simple result. So for each plane, so here we see we're just looking at this plane here, and we've got 1, 2, 3, 4, 5, 6, 7, etc. in the order that we've received those records. Much easier to work with that in Power BI than trying to create DAX calculations on the time, because all we need to do to find the very latest record for that plane now is filter it to rank 1, and we know that that's the most recent record that we've received. And when it comes to writing DAX, simple is best, right? So let's update our flight history function so that it now looks like that. I'm going to remove this map, and I'm just going to update our Power Query connection quickly. Hit refresh, just so that it updates, hopefully with the new fields. Hit close. Has that worked? Maybe. I don't think that's, there we go. So now we've just got that small subset of fields, but importantly, we've got our new rank column in there. So let's see if we can improve on the map. So now Azure Maps won't let us either draw lines or draw planes. So I'm going to use my custom visual that I referred to earlier called Icon Map, which is available in AppSource. So you can click on the 3 dots there, get more visuals, and use Microsoft's Marketplace for visuals. But I'm actually going to use a slightly newer version from the website than is available on AppSource. I'll explain why in a moment. So what do we want to have a look at? So we want to have a look at each plane. Now I could drag in longitude and latitude. We don't want sums, we want averages. And then let's for now just use altitude. And we get some circles. Now we don't get circles where those planes are now, but if I dragged in rank, we would get, if I filter that to is1, as I explained a moment ago, those circles now represent the latest locations of those planes. But we still got circles, right? We haven't got planes. So what I could do is I could jump in here and type in the URL of a picture of a plane. So let's try that. There we go. So I've got some planes. That's a good start. But actually, what I would prefer to have is the flight paths. So I draw that line of where the plane has been. So let's start there and come back to drawing the planes in a moment. So let me clear that out, go back to circles, and I've cleared my filter out, so now I've got all of the data again. What we need to do is construct a line for each plane. So in the same way as I don't like writing KQL in front of an audience, I certainly don't like writing DAX. So here's one I prepared earlier, but I will show you what it's doing. So here's our flight path. It's going to create a string, and it's going to create a string of geographic data called a line string, which is essentially just a list of longitude and latitude points that creates the line. Then I'm going to use the DAX function concatenate x, because we've got on each row the locations for each of the planes. So all it does is it takes the rows for each plane and creates a single string, which we're comma separating with those coordinates. And we've got that combined coordinate field I created in KQL, just to make life a little bit easier here in the DAX. And then we're ordering it using our rank, and we're putting it in descending order so that the very last thing we draw is the latest position of the plane. So let me hit enter on here, and we'll get our new function, hopefully. Yeah. I'll just show you what this looks like then. So for each plane identified by a hex field, we get, I'm going to have to remove the total, aren't I, for this to display? Yeah. So that's big enough to see. So basically, for each plane, we get a line string, a set of longitude and latitude coordinates in the format, geographic format, that we can then display on the map. So where I put in the plane icon before, I'm going to use conditional formatting just to select that new DAX measure. And hopefully, no longer have point data. We've got lines, so just remove the longitude and latitude. And we get our lines representing our plane locations. For the last, well, we've got more than 5 minutes worth of data here because I haven't done the parameters yet. But I want a plane at the end, right? So I showed you how to enter a plane URL a moment ago, but actually, let's use a SVG image and keep it inside of our Power BI dataset. Got another little DAX measure, which is just a SVG encoded picture of a plane. Go away. And you'll see here we've got the option to display an image at the end of a line. So if I now do the same thing and select my plane, airliner, that'll do. We should get the plane appearing at the end of our string, and then I can use the image rotation field. We just need to use and create another DAX measure to get the very last. Basically, we're pulling out the compass bearing from our data where the rank equals 1, so it's the very latest direction that the plane was pointing. So if I select that in here, latest rotation, our plane should now point in the direction of travel. Now let's clean this up a little bit, make it a little bit easier for everybody to see. So let's stop the map zooming around. I'm going to make our pictures slightly less transparent, so planes are a bit easier to see. Still not easy to see, so let's make the background grayscale and a bit transparent so everything stands out. And actually, because our plane is a SVG image, I can edit it, and let's change them from being white to red maybe, and then we really should be able to see where our planes are. Should we make them a bit bigger too? minimum size, let's go 30 pixels. There we are. So now we have our map of planes. How long have I got left? 15 minutes, perfect. So at the moment, we're viewing all of the data. Let's see if we can create a parameter inside of Power BI so we can pick how much history we want to show at any one time. So to do this, I'm going to go back into Power Query and create a new parameter here. So let's call that history. It's going to be a number, and we'll default it to 5. And then back in the call to our function, I'm just going to use the advanced editor because it's easier. So remember, I put in 5 because I couldn't work out how to do 5 minutes at the start. What that's done here is it's created this duration element with 5,000, so that's 5 days. So I don't want 5 days, so we'll 0 that. 5 days, hours, minutes. And if I type history here, it'll use a parameter value instead of a hard-coded 5. But that's still hard-coded. See, now we've removed a lot of the data in there, and we're just looking at the last 5 minutes, but it's still hard-coded inside of Power Query. What I want is the user of reports to be able to change this on the fly. So last thing in here is to create a new parameter in the data set for a numeric range. So let's do 1 to 60 minutes. Still default it at 5. It'll create one of these parameters down here and give us a slicer. Let's move that up here out of the way. But at the moment, this slicer isn't connected back to our KQL query. To do that, I just need to go into the model view, pick our parameter, and then in these advanced options, I can say I want to bind it to my history parameter in Power Query. And let's just make that a drop down rather than a list. Zoom in a bit. So, struggling on the zoomed in screen, bear with me. Where's my slicer gone? Here. Right, so now if I choose different values in my slicer, you'll see we go from 1 minute to 5 minutes, and we can go all the way up to, I think I chose 60, didn't I? It's the maximum number of minutes. And we'll go back to pulling all of that data in. So we're now dynamically calling the parameter all the way back in our KQL function, and we can dynamically change what we want to pull back out of our KQL DB on the fly. So we're nearly there. I've nearly got a near real-time map, which I've parameterized to choose how much data I want to pull back. But it's not real-time, right? We're just looking at the data when that query happened to run. So last step is to choose the formatting options for my whole Power BI report page. And down here at the bottom, set page refresh. And I'm going to tell it I want it to update every 5 seconds. And then hopefully, see if we can see this working. We should get our planes every 5 seconds. They will hopefully move. There we go. If you can see that, every 5 seconds, our planes will reflect the latest location of where they currently are in the sky right now. And then we can add tooltips and labels and improve this further. We can pull in additional metadata using that hex value to, say it's our British Airways plane to Seattle or whatever it is. But we've done the core part of creating our real-time data. So we've got about 10 minutes left. Yep. 11 minutes. So there's 2 more things I want to show. Let's see if we can create that alert to see if the planes are going to land on our head. And then the other thing I want to show is using that data in the KQL database, see if we can have a look at long term. So I don't know if anybody does live around the Farnborough area, but there's actually a a case out planning application at the moment to increase the number of planes that are able to land into Farnborough. So wouldn't it be great to have a look at the impact of all of the air traffic over time and see, where the noisy bits of airspace are and where you really don't want to buy a house in Farnborough right now because it's only going to get worse. So let's do that bit first, actually, and then we'll do the data activator bit last, as we're currently in Power BI. So again, we're going to do it with KQL. So I'll jump back into my query set. And I'm going to create a new function. And we're going to use, how we're going to do this is we're going to use a piece of spatial aggregation technology created by Uber, taxi company. And what they've done is they've split up the whole of the globe into hexagons. And then according to how many planes happen to pass through that hexagon, we're going to shade it in a darker color. And then hopefully we'll see the pattern in these hexagons over all of the time so far of where these planes have been. And KQL can do this for us. So I'm going to create this new function called h3cells. I'm going to take our flight data. I'm going to count I'm going to create a summarized list counting how many times these planes fly over each of these cells, and KQL actually has a geospatial function built in to create these cells. So I can probably show you actually. Actually, maybe not easily quickly, but I'll show you in a second. And then what we're going to do is ask KQL to give us the longitude and latitudes of each of those KQL cells so we can plot it on a map. So let me create that function here. And show you what it looks like. So now we have a unique identifier for each of these hexagons, how many times a plane has flown into that hexagon, and then here we just have, in the same format as actually no, this is GeoJSON, slightly different format to we used before, but basically it's a list of longitude and latitude coordinates that make up the 6 points of that hexagon. So if I jump back to Power BI, let's create a new page. Connect back into KQL DB and use our new function. And I've created a parameter as to how big those hexagons should be. Probably haven't got time to parameterize that, so let's just hard code it to random 6 for now. Connect to the data, and then if I add in our map again, see if I can get this right first time. Here's our new table of data. So if I pull in our cells, we've got the count of how many times the planes have flown in there. I'll reference that GeoJSON field in here, which I think is cell. And we get hexagons. And then I can just use normal Power BI conditional formatting to change the fill color on these with a gradient based on that count field, which it's actually done. That looks good. Maybe. So I picked the wrong field. It's not that one. Oh, did count of cells, not the actual count field. That's better. So already, just in the few minutes that we've been running this, you can see now, hopefully on the screen, that we've now got some darker areas already appearing of where we've got more flight traffic. And in just the last few minutes, it appears that you don't want to live in Cobham. I don't know. And obviously, we can change that parameter and make these hexagons even smaller and get a much more precise pattern of where those planes are flying. OK, a few minutes left, so let's jump back into Fabric and see if we can create that data activator alert for emergencies. So jumping back into my event stream. Now, at the moment, we've just got a simple flow from the source straight into KQL, but we can split our data and send it multiple ways at the same time. So I'm going to create that new reflex now. Give it a name, We're going to keep it in the same workspace, and I need to create a new reflex because we haven't got one yet, which I can do without moving outside of the Eventstream UI. Hit add, and that's going to go away and create our new data activator reflex artifact in the background. So you can see now I've got data traveling in both directions from my event stream. So if I jump back into the workspace, oops, that's not the workspace, that's the workspace. Here's our new reflex. So in here, it'll just take a moment just to pull in some streaming data to give us something to work with. So it's seeing our events flowing through. It gives us a little preview of them. We need to create a new object, which is going to be for us an aircraft, which is identified by that hex field. And we are interested in the emergency field. So if I hit save and go to design mode, then I can create, just wait for it to refresh. I can create a new trigger based on that emergency field. Now, if there's no emergency, that emergency field says none. And when we want to worry is when it doesn't say none. So I'm going to detect when it is not equal to none, and then choose what I want to happen. So I can either create an email. It's probably not going to let me know in time. I can create a Teams message. Yeah, that's not going to help me now, is it? Or I can create a custom action. And with a custom action, I can do things like call out to external APIs, or I can call Power Automate to do a custom activation and maybe make my phone ring out loud and tell me to run out the building and try and remember to tell you guys on the way. But hopefully we're not going to have any emergencies, so this isn't actually going to trigger, but hopefully you see just how simple it is to configure one of these. I just go in there, say what I want the text to be, and I can include any of those fields. I just ticked emergency, but we can actually include the raw data from that emergency field in there, so we can see how quickly we need to run out the building. Okay, so I think that's everything that I set out to achieve. We've created our real-time streaming report. We can see where the planes are on the fly in real time. We've got our emergency to run out the building if it's going to crash on us, and we can look over the long term and see where the noisy areas of air traffic are. All created completely from scratch in 50 minutes. Thanks very much. Please do remember to leave feedback, but in the last couple of moments, has anybody got any questions? Okay, thank you very much.